Assalamu alaikum. My name is Habibullah 2020E79. Today we discussing lab number 4 of digital signal processing. In task A, there is a question: how would you differentiate between a signal and a system? Explain the key characteristic of each and provide example to illustrate their role in the context of the signal processing. So the answer of this question is: in signal processing, a signal is a time varying or spatial varying quantity that carries information. It can be electrical or optical in nature. A system, on the other hand, is mechanism that process the input signal to produce an output. The key characteristic of a signal is its information content, while a system is defined by its behavior in transforming or manipulating signal. For example, in audio signal, like music in a signal, a speaker or amplifier represent a system that processes this signal to produce sound. In task B, the question is, how does linear time invariant system play a crucial role in digital signal processing, considering their mathematical simplicity, adherence to superposition principle, and efficiency in frequency response analysis? So the answer of this question is: linear time invariant systems are fundamental in digital signal processing due to their mathematical simplicity, adherence to the superposition principle, and efficiency in frequency response analysis. These systems exhibit consistent behavior over time and possess linear and shift invariant properties, allowing for straightforward mathematical representation. The superposition principle enables the analysis of complex signals by decomposing them into similar components. Additionally, their response analysis is efficient, providing insights into how the system responds to different frequencies, crucial for designing and understanding digital filter in DSP. In task C, the question is, what are the common methods for signal decomposition, especially focusing on technique like impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. Explore how these methods contribute to breaking down signal and their application in signal processing. The answer of this question is: common method for signal decomposition including impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. Impulse decomposition involves expressing a signal as a sum of scaled and time-shifted impulses. Step function analysis breaks down signal based on their step response. Even a decomposition separate into even and odd components. Fourier analysis decomposes signal into sum of sinusoidal component, revealing their frequencies content. These methods play a crucial role in signal processing, allowing for better understanding of signal characteristics and facilitating the design of filter and other processing technique. Task D. Question is, what is convolution and how does it play a significant role in digital signal processing system? Explore the fundamental concept of convoluting and elaborate on its importance in various DSP applications such as filtering, signal processing, and system analysis. The answer of this question is: convolution is a mathematical operation that combines two signals to produce a third representing the integral of the pointwise multiplication of the input signal. In digital signal processing, convolution play a crucial role in applications such as filtering, signal processing, and system analysis. It is a fundamental for understanding how signal interact with system, enable tasks like convolutional filtering to extract specific feature or analyze the response of system to input signal, making it cornerstone in various DSP algorithm and application. In task E, the question is when do we correlate two signal and what are the key application or scenarios where signal correlation is crucial in various fields such as communication system, radar and sonar image processing, biomedical signal processing, control system, wireless communication, and seismic signal processing. The answer of this question is we correlate two signal when we want to measure the similarity between them or identify pattern of interest. Signal correlation is a crucial in communication system for demodulation and error detection radar and sonar for target identification, image processing for pattern recognition, recognition, biomedical signal processing for event detection control system for feedback analysis, wireless communication for channel estimation, and seismic signal processing for identifying subsurface structure. Correlation is a fundamental tool across various fields, aiding in tasks that involve matching or comparing signal for meaningful analysis and detection making. Moving towards task 1. In task 1, we define a function that is convolution graph. Then we take a signal x from some user and also take a signal h from some user h. Then we convert both these signals x and h. Then we use figure command for producing figure, then use subplot, then use stem from producing x, then use title input signal, then subplot 312, then stem for producing h signal. Then use title, then again we use subplot and then use stem for producing convolution of both x and h, and in the last we give the title output signal and then end. The output signal is like this as shown in the output. This is the input signal x, input signal h. When we convolve both these signal we get the output signal like this when we convolve both these signal. Moving towards task 2. In task 2, first we add T start, which is the combination of T1 and T2, then produce T end. Then we find difference between T1 and T2. Then using for loop from N1 to L length H, then use figure, then stem command, then use X label for leveling in X axis, then use Y label for leveling in Y axis, then use title, then use axis, then use grid on, then use pause command. Again we define input signal, that is T1 range from -1 to 1, then we exponential, then define T2, and in the last we convolve both the signal by using flip and slide method. At the end we get output like this. In few seconds we get all these samples which are convolving. Moving towards task 3. In task 3 we define a convolution that define NYB, NYE, NY, and in Y we convolve X and H. Now we define a range of X, then define range of NX, then define range of H, then define range of NH. And in the last we convolve X, NX, H, NH and use stem command, and in the last we give title. As a result we get an output like this. moving towards task 4. In this task, first we define h, then define x, then in y we convolve both these x and h. Then use subplot, then title, then again use subplot, then give same command to define x, define h. Then give title again, and then use subplot, and again use stem for defining y. Give title, give x shifted, y shifted, use figure, then use stem, give title to shifted input signal, again use subplot, and again use stem command, then y shifted, give title. As a result, we get output. So this is the input signal, this is the impulse response, and when we convolve both the signal, we get an output signal like this. And this was the shifted input signal and the output signal for shifted input. So these all tasks from lab 4. Thanks for watching.